Hello, this is CP Edit, and in this video we'll be solving this problem, all elements in two binary search trees. So in this problem we are given two binary search trees and we have to return all the elements of these two binary search trees after sorting. So for example, the two trees are 2, 1 and 4 and 1, 0, 3. The result will be 0, 1, 1, 2, 3, 4. So let's discuss all the approaches for this problem. So first approach is pretty simple. We can do the traversal on both the trees and merge the result and then we can sort. So first approach is to traverse, then merge and then sort. So in second approach we can remove this sort part because we know the in-order traversal of a BST is already sorted. So we can use as traverse and then merge, and the traversal would be in order. So this approach will take order of n plus m time and order of n plus m space. So I'm writing time here and space here, and it will take order of n plus m log n, space will be order of n plus m. So yeah, so now I'll be discussing another approach which I use to solve this problem. So in this approach what we can do is we can solve another problem called BST Iterator. So we can create a iterator on the binary search tree and it will return the smallest next element on every time the BST Iterator.next is called. So what we can do is we can keep finding the next of we will be having iterators on both the trees, have iterators on both the trees, and we'll be appending the element which is smaller at the current iterator. So append the smaller element from both the iterators. So the complexity of this solution depends on the way you implement the iterators. So there are various ways to implement the iterators. So I'll be discussing how I solved this problem. So we have created another class called BST Iterator and it has three functions: dot next function, dot peak and dot has next. So has next function returns if we have traversed all the elements or not. Peak element returns the value of current element, and next element removes the current value and increases the iterator by value 1. So it will move the iterator to next value also. So we have two iterators for both the trees, iterator 1 and then iterator 2. While each iterator is having at least one element, we'll be pushing the smaller element by calling iterator.next, and then when at least one of the tree is empty, we can add all the elements of the remaining tree. So that's all for this approach. Now let's see how we have implemented the BST iterator. So we know that in a BST all the elements on its left are smaller than root and all the elements on right are greater than root. So if we are traversing a tree, so let's say this is our tree. So let's say this is our tree. So the smallest element will be this node. The leftmost node will be the smallest element, and second smallest element will be this node, and the third smallest element will be this node. So what we can notice is we just move to the left of the tree, and when we reach the leaf, we just have to move up, and this will be the second smallest element. And after that we have to move to the left of this subtree. So suppose the tree also had these two elements. Now pause for a second and tell me what will be the third smallest node. So the smallest node will be this, second smallest will be this, and third smallest will be the this node. So whenever we reach a leaf, that will be the smallest node, and after that the parent of that node will be second smallest, and then we have to find the smallest node on the right subtree. So we'll be moving left on the right subtree of this node. So whenever the left part of this node is completed, we move to the leftmost part of that node, and then so on and so forth. So after using this node, we have to move to this node and then this node. So if we had these two nodes, so the node which is next of this node will be this one. So in order successor will be the leftmost node in the right subtree. Okay, so we have used this same approach. We have pushed all the left nodes on the stack. So when we call the constructor, we just add all the nodes of the left part, the leftmost branch on the stack. So we are pushing all the leftmost branches on the stack. So you can notice that the smallest node will be on the top of the stack because we have pushed all the nodes of the leftmost branch on the stack. So after that, when next is called, what we do is we just return the topmost value, and what we do next is we just push all the left nodes of the right subtree on the stack, so that the top of stack always contain the smallest node. So we have used this iterator in this problem. So let's talk about the complexity of this problem. So complexity for this solution is, for time complexity, it is order of n plus m. For space, it is order of height of root 1 plus height of root 2. How this comes? Because on the stack at any point there will be no more nodes than the height of the tree. So we are maintaining two iterators, so the height will be order of these two heights. So this can be improved by various other traversal approaches like Morris approach. So I'm not going into that in this video. Hope we'll solve that problem in next video. But this is about another approach for this problem. So that's all for this video. I hope you liked this one. See you in the next one. Please like, share and subscribe our channel. Thanks.